All right, hey folks. So in this video, we're going to talk about simplifying square roots, sometimes also known as radicals. And there's, as always, different methods that you can use, but in this video, I'm going to focus on what you might call the prime factorization method. So another method you might know the name of is called the perfect squares method. This video is not going to be about that, but I'll see if I can make another video on the perfect squares method. So before we get started, one thing that might be helpful to know, a prerequisite skill, is being able to get the prime factorization of whole numbers. So if you're not sure if you can do that, you might watch the first one or two examples and see if it makes sense, but otherwise I'll see maybe I can link to some practice on Khan Academy or IXL. All right, so using this prime factorization method, I thought it just might be helpful if we listed out some of the prime numbers. I just went up to 29, going less than 30. These numbers, prime numbers, they really keep going forever. It's an infinite list, but for what we're going to do, I doubt we're going to need to go up much higher here. So how about we just jump in and try out an example here? But we just jump in with an example here. Simplify the square root of 45. First of all, what we might want to do is we might want to get an estimate and say, what is this approximately? So if I punch this into the calculator, what is that going to give us here? So on the calculator, if I do 45 square root, we're getting 6.708 approximately. I'll jot down a few of those digits, 6.708. But that's an estimate. That's an approximate value. If we're supposed to give an exact value, a simplified but exact value, what we can do is we can start by saying, all right, let's break down 45 into only prime numbers. So this is going to be the prime factorization part. So if you know how to do this, many ways that you can break up 45, but I might say, well, I know it's 5 times 9. By the way, if you wanted to use the perfect squares method, 9 is a perfect square number. 5, though, is on my list of primes, so I'm stopping with the 5 there, but the 9 can break down to 3 times 3. And the 3s are prime. Those are on my prime number list. So 45 could be broken down as, I usually like to put these in order from smallest to largest. So 3 times 3 times 5. We can verify that. Make sure that we did the prime factorization correctly. Let's try 3 times 3 times 5 and make sure we do in fact get 45. Okay. But so now when we apply the square root, here's what's going to happen. When we do the square root of 45, it's the same as the square root of all that. And the trick here is that any pairs of the same number inside will come outside the square root, but as a single. And I'll type that up here. Okay, so we've got a pair of 3s on the inside that gets to come outside the square root as a single 3. Now the 5 doesn't have a partner. There's not another 5. So that's going to stay inside the square root. And that's it. We've got 3 square root of 5. I guess I don't need parentheses around the 3. But that should be our answer. The only other thing I'm going to do here is I'm going to try on the calculator. What happens if I do 3 times the square root of 5? So 3 times on this calculator, I have to put the 5 first, then ask it for the square root. I'm hoping to get, I haven't pressed equals yet, but I'm hoping to get that 6.708. Here comes on the equals. 6.708 looks familiar, so seems good. That'd be our final answer here. The square root of 45, it's approximately 6.708, but its exact simplified value is 3 times the square root of 5. Okay. Let's do another example. All right, so another square root here, this time the square root of 126, if we want to simplify it. Again, I might just start out by trying it on the calculator, see what the estimate would be. Square root of 126, 11.224, 11.225 I'll go with. I'll say 11.224. I'm not rounding it here. But 11.224, it keeps going. That's the square root of 126. So let's see if I want to break this down into prime numbers. So 126, it ends in a 6. It's even. I could say it's 2 times something. If I say 2 times something equals 126, if I use my algebra skills, I divide that by 2. 126 divided by 2 is going to give me 63. So 2 times 63 would give you 126. 2's prime, that's on my list. 63. 6, 3. I think this might be divisible by 3. Or actually, hold on a second. 7 times 9. That's a math fact that we know. 7's prime. There we go. 9, I think we saw it in the last one, can break down to 3 times 3. So just getting the prime factorization of 126, it is, again, if we put these in order, smallest to largest, 2 times, we got a pair of 3's, times 7. And so let's verify that that is correct. So make sure we didn't miss a number. We're going to do 2 times 3 times 3 times 7. And that gives us 126. Okay. So now if we're doing the square root of 126, that's the square root of all these numbers. And we said any pairs of the same numbers come outside as a single. So 2. I don't have a pair of 2's, so we're gonna keep a 2 inside the square root, but I do have a pair of 3's. So I get to bring out a single 3. The 2 and the 7 don't have partners, so those are gonna stay inside. Now here, this is a little bit different than last time, because I notice I do have 2 times 7 inside, so I'll go ahead and I'll multiply the 2 times the 7. That's 14, so I get 3 times the square root of 14. And let's try that. If we do 3 times the square root of 14, I'm hoping to get that 11.224. So 3 times 14's square root equals 11.2249. Looks good. So there's my answer. 3 times the square root of 14. Okay, we'll do a few more here. Let me just box that in as our answer for the square root of 126. All right, so another example here. This time let's do the square root of 132. And again, I'm going to start with a calculator estimate. 11.489. All right, so again, I'm not worried about rounding right now, I guess, but 11.489. All right, so keeps going. If we try to break down 132 into its prime factors, again, it's even, ends in a 0, 2, 4, 6, or 8, so 2 would be a factor. If I think to myself, 2 times what gives me 132, I could solve this by dividing by 2. If I do 132 divided by 2, that gives me, I think that's 66. Let's double check that real quick. 132 divided by 2. Okay, 66. All right, so 2 times 66 would be 132. 2's prime, it's on my list. 66 could be 6 times 11. 11's prime. Okay, but 6 can break down to 2 times 3, and the 2 and the 3 are prime. So we got 132 broken down. If I put these in order, we got a pair of 2's. We got a 3. We got an 11. Let's make sure that we didn't miss anything. If we multiply 2 times 2, whoops, 2 times 2. 2 times 2 times 3 times 11, 132. Okay, and then when we apply the square root, we've got we got a pair of 2's that gets to come outside as a single 2. The 3 and the 11 don't have partners, so those are going to stay inside the square root. And then I can do a little more simplifying. I can multiply inside the square root of 3 times 11. Whoops, 2 times the square root of 33. So the only other thing I'm going to do here is calculate 2 times the square root of 33. Hope to get that 11.489. Let's see here. 2 times 33's square root is equal to 11.489. Looks good. Okay. Box that in. We'll do 2 or 3 more here. But so square root of 132 simplifies to 2 times the square root of 33. All right, square root of 300 is our next example. I already did this on the calculator, 17.320. So now I'll see if I can break down 300 into prime factors. You might know that, let's see, 3 times 100 is 300. 3 is prime. If you were doing the perfect squares method, 100 would also be a perfect square number. But if we're doing prime factors, we might break 100 into 10 times 10. And each of those 10s can break into 2 times 5, and the 2 and the 5 r prime, but we got both of those here. So if we're doing 300 in its prime factored form, again, if I do this in order, we got a pair of 2s, we got a 3, and we got a pair of 5s. So when I put the square root on, the trick is any number that occurs in pairs, any pairs get to come outside as a single. So a pair of 2s, we got a single 2 comes outside. 3 doesn't have a partner, but the 5s, we got a pair of 5s. So those get to come outside. And then the 3's just going to stay inside. And we've seen this inside a couple times now, but now I've got 2 times 5 outside. I can do 2 times 5 and I get 10. Square root of 3 stays the square root of 3. So if I do 10 times the square root of 3, I should get the 17.320. Let's try it. 10 times 3's square root equals 17.320. Looks good. So that would be, again, I'll box that in. Square root of 300 simplifies to an exact value of 10 times the square root of 3. Okay. We'll mix up a couple ones that I've seen on IXL where there's a little bit more. But let's look at another one here. All right, so now a little bit of a twist here, and this is similar to what you might see on IXL, something where they're giving us a number outside the square root, but we're still supposed to simplify this. So what I'm going to do is I'm going to focus on the square root part. The 11 we're just going to keep to the side for now. I put in the estimate already, 11 times the square root of 375 gave me a little over 213. So for just the square root part, if I take the 375 and I try to break that down, well, let's see, I know it ends in a 5, so it's 5 times something, and 5 is a prime number. Let's see, 5 times something is 375. If I divide by 5 to get just that number, and I divide this by 5, I believe that's going to be 72. No, 70, oh boy. Let's go to the calculator. 375 divided by 5. 375 divided by 5. 75, there we go. Sounds better. So 5 times 75, trying to break it down to prime numbers. 5's prime. 75 is another number that ends in 5. So that could be 5 times something. Let's see, 5x equals 75. Then x would be 75 divided by 5, which I believe that one's 15. I'm quite certain of that. 5 again is prime. 15 is 3 times 5. Those are both prime. So I believe we can say, again, remember, I'm going to come back to that 11, but for now I'm going to have 375. I'm going to leave a little bit of space here, but I'm putting these in order. 3 times 5 times 5 times 5. Let's just double check that. 3 times 5 times 5, make sure that is 375. 3 times 5 times 5 times 5. 375 looks good. So then I'm doing the square root of 375. And then also don't forget we've got the 11. So now I'm going to bring that 11 back. And remember, I left a little bit of space here, okay? But so we've already got the 11 outside the square root. So that's just going to stay there for now. But now I can use this reasoning. Any pairs of the same number inside come outside as a single. So the 3 doesn't have, we don't have a pair of 3s, but I do have a pair of 5s. So I get a single 5 gets to come outside the square root. And then this 3 and the other 5, they don't have partners, so they have to stay inside. And so this time I've got a little bit of multiplying. I can do both outside, 11 times 5, and inside the square root. So let's double check this. 55 times the square root of 15. I'm hoping to get 213.04, but let's see what happens. 55 times 15's square root equals 213.014. All right, so again, something you might see on IXL, where they give you, they start you with a number outside the square root. You just hang on to that and deal with the square root, and then in this case that 11. Once you figure out what's coming outside the square root, multiply it with that 11. Okay, we'll do one more. All right, I think one more example for this video. So we're going to simplify 8 times the square root of 490. So I've already put it on the calculator. It comes out to a little over 177. But if I'm using the perfect squares, the prime factors method, remember I'm gonna put that 8 on hold and I'm gonna focus on the 490. So breaking it down with 490 ending in a 0, you might say, oh, that's 10 times 49. And again, if you are doing the perfect squares method, 49 is a perfect square number. So that might make things a little bit quicker. But we are doing prime factors. So let's see, 10 can break down to 2 times 5. And those are both prime. And 49 is 7 times 7. And 7's prime. So it seems like we got for our 490. And you remember we got the 8, so I'm going to leave a little bit of space to bring that 8 back. But what do we got? 2 times 5 times 7 times 7. I'll just double check that that works out to be 490. Pretty sure on that one, but let's see. 2 times 5 times 7 times 7 is 490. Okay. We're doing the square root of 490. So we would also do the square root of all those prime numbers, the product. But now this is where I need to bring that 8 back and say, all right, so 8's already on the outside of the square root. What's going to join it? Well, the only pair inside that I have is a pair of 7s. So a single 7 comes outside, and inside that 2 and the 5 will stay. And then if we do the multiplication outside, 8 times 7 is 56. We do the multiplication inside, 2 times 5 is 10, that's inside the square root. And then let's just check here, 56 times the square root of 10. I hope we get that 177. 56 times 10's square root equals 177.087, so it looks good. So yeah, so I hope that video helps you. And again, I'll try to link, if you need practice with finding the prime factorization, I'll try to link to IXL in Khan Academy. But yeah, we'll see you next time.